Welcome to Chemistry online lesson with me, Mr. Nkandu. Today's lesson topic is organic chemistry, which is one of the topics you have to study during your 3 years course of our Zambian syllabus. And with this topic, with this knowledge, it is very much important that it will equip us with the understanding on the composition of natural produce, like the one that you can see here, and how we understand with the same knowledge we understand the composition of this sugar, the composition of these lipids, proteins, nucleic acids such as the DNA, and we also understand how materials that are used to make these plastic shoes are made, and how the materials that we use to make these clothing are made, and how also these carrier bags that we call plastics bag, also how they are made. So it is through this knowledge of organic chemistry that all these things will be understood and studied further. So stay tuned as we advance in our lesson. So to start with, we need to understand what organic chemistry is. So we need to define what organic chemistry is. So organic chemistry is a study of carbon and its compounds. So saying it's a study of carbon and its compounds. This means that carbon combines with other elements or atoms of different elements to form a wide range of compounds, such as CH4. I don't know what this one is, but it looks like methane. C2H6 or so. Yeah, it's one of the examples. So we have methane here, we have ethane here, and such compounds that we're talking about to be organic compounds. Now we have compounds that does not qualify to be organic compounds, and these are some of the exceptions. So how do we qualify something to be organic? We're saying every organic compound that is formed in those it has to give us carbon dioxide and water only when it undergoes combustion, like this candle here, in plentiful supply of air, and air in this case we talk of oxygen. It should give us only carbon dioxide and water. So if I react this CO2 plus that, I get water and carbon dioxide. So this is how we tell to say this is organic and this is not organic. So as the saying goes on that all organic compounds contain carbon, here we have to understand that yes, we understand to say all organic compounds they contain carbon, but it is not every carbon containing compound that is classified under organic. Some of them are inorganic, like this exception that I gave here. So the exceptions that I gave, we said carbon dioxide, carbonate, hydrogen carbonate. We might also have compounds such as sodium. Okay, pardon me on this one, carbonate. I just couldn't figure out how to do that. Okay, so this is another exception. So we have this, and these are 3 exceptions that does not qualify carbon to be organic. Then why are we studying carbon? Why are we studying carbon? We need to understand why we are studying this organic chemistry. So in our quest to study this organic chemistry, we have to understand some of the facts about carbon. Like, for example, we're saying carbon is found in nature both as an element or in combined form. Meaning I can find carbon as just in native state, or I can find carbon in form of the sugars, in form of the lipids, in form of the molecules such as proteins. Those are examples where you can find carbon combined. Of course, we have a bunch of carbon dioxide in our atmosphere, and we're saying this carbon is we're saying this carbon is ranked 17th. It is ranked 17th in abundance by mass. So it is ranked 17th in abundance by mass on the Earth's crust. So this is the carbon we're studying. It's 17th in the atmosphere, approximately, by that, if I'm not mistaken. Then we're saying it is exceedingly important because it is found in all living matter. So we are saying this carbon we're dealing with today, we're studying today, is found in all living matter. Carbon is present in our body tissues, carbon is present in all the food substances that we eat, and it is also found in common fuels such as coal, petroleum, natural gases, and some food. So we find carbon in the food we eat, the enzyme we abuse. On the fuels, like we have whatever is burning there. We have coal, coal simply means carbon. We have wood, and we have the natural gases. Of course, we have other means of burning that we use. We have natural gases such as methane, ethane, propane, butane, and you can mention some more of that. Those are some of the organic compounds that we have. Now, that's where we have carbon being found in abundance. So the truth that we have to know about, the fact that we have to know about carbon is that it is found in group 4 of the periodic table. It is found in group 4 of the periodic table. So on that periodic table, with your knowledge or with your understanding on the periodic table, you have to always remember that in group 4, period 2, you have carbon being present in that periodic table. So there we're saying if it is in group 4, it simply means it has the 4 valence electrons. And if it has 4 valence electrons, we're simply saying when you check all the electrons that this carbon contains, it means that carbon has 4 electrons in the outermost shell. Now these 4 electrons, it simply means that when out of the 8 groups that we have, and you are saying it is in group 4, we subtract the group number, and when we subtract the group number, we get 4 as the valence. So meaning this is the valence electrons, and this is the valence for carbon. Now, if it has a valence of 4, it has 4 electrons. The outermost shell, it is found in group 4. The other thing that you have to realize is that if it's going to be stable, it needs to form 4 bonds with other elements or other atoms of a different element. And if that happens, we're saying carbon always should form 4 covalent compounds. So 4 covalent compound is what should be made. Single covalent compounds should be bonded to carbon. When this happens, we simply say, okay, that carbon is saturated. Now, the other thing, the most interesting thing about this carbon is that carbon can bond to itself. Carbon can bond to itself repeatedly through either single bonds or triple bond or double bond to form large molecules of substances. We're saying I can have carbon here being bonded to itself like that, and like that, and like that, and like that, and this means it can continue like that. We also saying it can we can go through double bonds arrangement. I'll do 2 lines there, and this can also continue like that. Or it can also use a triple bond arrangement like that, and this side it can continue, and it can continue like that to form either straight chains or branch chains or rings of itself. For example, we have rings such as benzene. So those are some of the compounds that this carbon can make. So if this ability that we're talking about here is a special property that is exhibited by carbon, that is called catenation. So I'm simply saying carbon exhibits catenation as the property. So catenation simply defined as the ability of carbon atoms to form bonds to each other through either single, double, or triple bonds, to form straight chains or branch chains or rings of a different different substance. So with that understanding, we're saying because of this catenation, carbon has the ability to form a variety of products, a variety of compounds, such as compounds as these we talked about here. Such compounds that we have sugars, we have lipids, we have proteins, we have nucleic acids such as DNA, and the joining we're talking about, if you look at this is carbon, that is carbon, that is carbon, that is carbon, and that is carbon, continuously bonded to itself through these single bonds. Those are the lines I was drawing. So when this happens, it is very much possible that through this arrangement of us bonding this carbon atom to itself, we can form a large molecule. It's like the molecule of DNA that is always found in our cells, that contains the genetic information that is supposed to be passed on from generation to generation. So every generation, of course, expects to have that. So every cell contains that DNA. So with this brief introduction, I'll leave it here until we meet next time. So stay tuned, make a date with us. Every time we have a lesson, follow the timetable that we're going to give you, and the lessons are coming in segments. And please remember to subscribe, and tell a friend to tell a friend to tell a friend and tell a friend, and subscribe. Please stay safe, stay quarantined. Corona is real. In Jubak. Thank you.